Hi everyone, in this video we're looking at determining the linear function. So in other videos we've looked at sketching them from the equation. So if you've been given the y equals mx plus c, in this one here we're going to be determining it based on either some graphical information, so here's a straight line on a graph, calculate it, or here's a whole lot of values from your graph, determine the equation for this straight line. So that's what we are looking at today. So again, the y equals mx plus b or c, we are looking for these features. So sometimes they might not necessarily come to you, but if we use this concept of this is the general form for our equations, then it won't be too much of an issue. So we had a look at this one here in another video, and I've just removed the rule. So it's essentially like if you got this information, how do I derive, or how do I determine, more so derive is a different type of mathematical concept. How do I determine that is the formula for my straight line? So that's what we are looking at in this video. Now, if you're really stuck, you can actually look at the difference between these things here. You've been given the intercept already because it just happens to be passing through it. It's pretty nice and clear. Sometimes it's not always like that. That can be the issue. But in this case here, you can see it's already like 0, 3. So you know that this value here means c equals 3. The gradient can be determined graphically. You could be like rise over run. So 1, 2, 3, 1, 2, 3. Your rise is 3 or -3, and your run is +3. So m equals -3 over 3, which gives us a value of -1. And therefore, if you substitute m and c into the equation, like the form y equals mx plus c, you'll find that it's y equals m -1 x plus 3. It gives you your value. If you necessarily write, convention states we just write it without the 1 in front. And voila, look at that. Da, 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 da. So what happens though when you get a graph that doesn't have all like this nice and neat? So I'm going to practice with a graph that does, but we can also in class we'll be looking at graphs when it doesn't nicely, neatly cut the axis. So the first thing you do when you're trying to work out from a graphical thing is you're going to think about like your x and y's from your coordinates and go from there. So my two pairs by inspection, my coordinates are 0 and 6 for this one, and the other one is 3, 0. So they're my ordered pairs. The first thing we're going to do is assign them like y and x 1 and 2. So I'm going to call these guys, I should have left a bit of space here, x1, y1, x2, y2. And I'm going to use my formula of gradient rise over run. What that is saying is like, what's the difference between each one of your y's and the difference between each one of your x's, and whatever the proportion of those things are, so it could be a whole number or a fraction, is your gradient. So m equals y2, getting excited there, minus y1 over x2 minus x1. This is your rise because you're going this way, and your x is your run, which is this way. So that's why it's rise over run. Substitute your values in. y2 is this one, 0 minus 6 over x2, which is 3 minus 0. 0 minus 6, -6. And 3 minus 0. So it's -6 over 3, which gives us a nice round value of -2, because -6 divided by 3 is going to give you a positive, negative value, negative, and 6 divided by 3 is 2. So that gives you your gradient. What we're actually looking for is the whole linear equation for this straight line. So now we can substitute m equals -2 and a pair of coordinates. Does not matter which one you pick, just pick one, into your y equals mx plus c form. So your y then becomes 6 equals m is -2, your x is 0 plus c. That's what we're looking for in this case. So -2 times 0 is still 0 plus c, and 6, anything minus 0 is itself, so c equals 6. So if I was to do that, not that you need to really, so minus 0, well, yeah, minus 0. So that is your y intercept, and you can actually see that by inspection through here. Not all graphs are always going to be that nice and easy for you. And then you substitute m equals -2 and c equals +6 into y equals mx plus c. So that's going to give us y equals m -2x plus c. If this was a negative intercept, it would be subtract, and we'll look more at that next up. So here is b here. B is passing through 2 points, and the first thing you want to do is assign them some letters, so x's and y's, and make sure that you've got like x1, x2, x2, and y1 and y2. So I'm going to call these my first pair, so x1, y1. Notice that the ones are relating to the first coordinate pair, and then the second one will be x2, y2. It's not xx or yy, it's each one of these an ordered pair. So the line is passing through those 2 points. The first thing you want to do is find the gradient. So m equals y2 minus y1 over x2 minus x1, and that gives us substitution in +1 minus 5, and that's going to be over +1 minus negative. The brackets would actually come in handy in this situation because you've got all these like negative value symbols hanging around. So it's -1 minus 5 gives us -6, and 1 minus -2 is actually the same as saying like 1 plus 2, which is +3. And that gives us, if we 6 divided by 3, 2, and it's going to be a negative, and divided by a positive gives us -2, and that is our gradient. And then when you go to find, so we've got a straight line passing through those 2 points, we have the gradient, we have a point, now we can find the intercept. So this is for B, and then we're going to find the intercept. So substitute, I'm just going to make that come up a bit, substitute, where is there, 1 m equals -2 into y equals mx plus c, and that's going to allow us to find c. So that's going to be -1 equals -2 bracket 1 plus c. We have then -2 times 1 is -2 plus c, -1, and we then take this value and move it over, so that becomes -1, which gives us our c value, and that is going to be 1. So c equals 1. Therefore your equation is going to be y equals m, which is -2, x plus, yes, we can do that, plus 1. That's the equation for that one there. And then what you need to do with c is you've been given a gradient and the intercept. So I'm just going to draw that in black. Okay, so with, move that up a bit, with C, your M value is 2, it's a positive, and your y-intercept C is -5. If you've been given that, you have a straightforward y plus C, so that's going to be -5. You see that there is a positive and a negative together. That's simplified is y equals 2. Is y equals 2x minus 5. So with D here, we've got a line passing through 5, -1, and it's already got a gradient established for you. So m equals 3, and then your line is passing 5, -1. What you're going to do is substitute both of those into your linear function in the y equals mx plus c form. Sub both into y equals mx plus c. So y in this case is -1 equals 3. Oh, don't know what happened there. 3 bracket 5 plus c. Don't know what that is at this point in time. -1. 3 times 5 is 15 plus c. You would then move your, I have to get an orange there for you. That's positive. Move that over. It becomes -15. So -1 minus -1 take 15 gets us -16 equals c. So therefore your c coordinate is, or your y-intercept is 0, -16. So to write your formula for D, it's going to be y equals mx plus c. So substituting in, y equals m, which is 3x. It's not a plus, it's a -16. So that is how you do determine the linear function from points on a graph. So in that you can have 2 points, just the gradient and the intercept, or gradient and 1 point. Alright, and what you are going to do is use the point gradient method to determine the linear equation for these situations here. Pause the video, complete the questions in your exercise book, ready for homework check for the next lesson. Okay, stay awesome everyone.